This is Samadru Sharma from Caffeine to Code, and let's get started with our 100 problem challenge on learning Haskell. So let's start with the first problem, and let's see. In this video, I'm gonna cover just the first problem because to get started with the language, we need to learn a few things such as compilation, the nature of the program, and what all things we are gonna use. So yeah, um, let's see where this discussion takes us. So yeah, what is the first problem? Find the last element of a list. So you have to technically find the last element of a list. A list is basically an array or a Python list if you're familiar with Python. So this is a function, and basically if you pass it an array, it should return the last function. So yeah, it's pretty decent. So the first problem is really easy. If it were Python or Java, you would have solved it like easily. And in Haskell also it's easy. But before writing the actual program, we should learn something about Haskell in general. So, so the golden rule of programming in Haskell is, or any functional programming, is that everything is a function. Everything is a function. So what is a mathematical function? A mathematical function is something which takes an input. So let me pull out the Wikipedia definition of mathematical functions. So a function is a relation between sets that associates blah blah blah. So it's not actually what we are interested in. So let's open this link. So basically, yeah. So a function is something which takes as input a number or an object in general. Numbers are also objects. So when I say object, you must consider it as the most fundamental element. So for instance, in our universe, those are the quarks and gluons and maybe electrons are the fundamental particles. So in similar way, the most fundamental thing is called an object. Everything is an object. I understand that it's not an object-oriented language, but we have to assign something to a particular entity, assign a name to that fundamental entity, or leave it. Everything is a function, but then, so I want to make you comfortable with the idea that even the numbers, the natural numbers 1, 2, 3 are functions in itself, but that might be difficult at the start. So let's consider everything is an object, which is a lot easier to start with. And so what is a function? A function takes something as an input, say x, and then it outputs something, an object, which might be a number, might be a string, might be anything. So yeah, so that is a function. So if the function is fx equals 2x, then if the input is 0, the output is 0. If the input is 1, the output is 2, and if the input is 10, output is 20. So these are some examples of functions. So the only thing you have to remember while programming a functional programming language is that everything is a function. It might be a bit hard initially to comprehend how everything can be a function and how to write programs only in functions. So the way people usually explain is that in normal object-oriented programming languages, you write how to do something, but in functional programming, you write what to do. So more on that later. I think we can go ahead with the first problem without going into the details. The only thing I want to stress from this page on signum function is that you see how the signum x function is defined here, -1, 0, 1. If x smaller than 0, then -1. If x equal to 0, 0. So that is basically, so this is the definition of a function, and that is how we are going to write programs in a functional programming language. So these are technically if-else statements in a functional language. So you know how to write functions using if statements, and if you can write function if statements within a function, you can actually, if statement is a conditional statement, so you can actually program in a function. So yeah, so this is how we are actually gonna write our programs. I know I'm not making sense here, but you'll get everything as we follow along. So let's start with our the problem one statement. Uh, so first thing first, to write a Haskell program, you have to create a file called which has an extension hs. So I created a file called challenge.hs, and let's start. So in a typical programming language, if suppose we are talking about Python, so if there's a function, if say square is a function, so basically I would write def square and then the parameters x, and then I would do something as return x star star 2. So this is basically Python. And how would I call the function is I would pass the parameters into the function name. But this is not how you work in Haskell. Haskell is basically a functional programming language. And how do you define a function? So let's start with a function that takes a number and adds 1 to it. Okay, so to define a function in Haskell, you have to create the name of a function. So I would create, this is my function. Function is nothing but mathematical objects. Now the input to the function is defined by a parameter which is entered after adding a space. So basically uh, this is equivalent to def add 1 x in Python. And to add comments, you start with minus minus and add comments. So add 1x. Now consider this definition. How do we write a function here? So we define the function, name, then we define the input parameter x, and then we are gonna define what this function is. So there's just x plus 1. Okay. So this is quite mathematical definition of a function. So you have to in mathematics we assign a definition to a function. We don't assign what the function does. So in Python, what I would have done is that I would have created something like this, and then I've said return x plus 1. So in Python, what I'm doing is I'm explaining the computer what to do. So I'm sorry, I'm explaining the computer how to perform calculation using this function. But in Haskell, I am assigning a definition to the function. This is just a definition. What is add 1x? It's x plus 1. Okay. So technically, I am supposed to assign meanings to functions in a functional programming language. And these statements which I'm speaking, assigning meaning, the functions being not how to do but what to do, these meanings will become clearer as we solve more questions and as we go along the series. But the only thing which we need to remember from this discussion is that it's the function name, it's the input, and if there are two inputs, we will write x, y, z, and then maybe x plus y plus z plus 1. So yeah, this is a function. We define functions and assign meaning to them. We don't write what instructions the computer has to follow. We just say like this is the definition of the function. And to run a function, in every programming language, we have a main function, and then let me call. So now, typically we would specify what the program has to do, but in this, I only assign meaning to what main is. We define what main function is. So it is nothing but add 1, 1, 2, 3. So it's similar how you call functions to the way how you define functions. So basically add 1 is the function, and 1, 2, 3 are the parameters of the function. And so basically I will also print the result here. So basically this print. So now come the parenthesis. So you don't actually need parenthesis, but to assign priority, we add parenthesis. So basically what these parentheses tell is that you have to first perform add 1 on these 1, 2, 3, and then to the result you have to perform this print function. So yeah, I'm gonna save this. Now how do you run this? So just go ahead and pull up your terminal. I will clear this terminal for you. So I have this challenge.hs file. What I will do is I will write stack, and then challenge.hs, stack space ghci and challenge.hs, and there has been some error configuring GHCI with the following packages. Okay, one module loaded, interpreted. One second, there is something wrong. Let me check out stack GHCI. One second. As I said, I'm also new to this stuff, and I'm also figuring things out. So let me check stack GHCI. Okay, let me try once more. Stack GHCI. Let me just quickly Google it. How to compile Haskell file, and yeah, maybe so I would find the let's try this command GHC. Okay, so GHC maybe okay. So what I did was I realized my mistake. So I typed GHCI and I stands for interactive. That's why it opened the interactive shell above here. So I don't have to include GHC, and then just what was our file, challenge.hs, and yeah, it compiled, and then just it would create a challenge file, a challenge binary. And then what you have to do is just you have to run the challenge. It printed 7. So let's see if 7 was the right answer. Yep. So it's 1, 2, 3, 3 to 6, 3 to 5, plus 1, 6, and plus 1, 7. So yeah. Now let's get back to our problem 1. So how to find the last element in the list. So okay, so now what I have to do is that I have a function called myLast, which takes in a list as input, and I have to define the definition. I have to define the function. So what it will do is it just has to return the last element of the list. So typically in Python, what I would do is I would, if x is a list, then I would get x, get the length of x, and yeah, that's base and minus 1. So that's basically the way to return the last element of the array. So let's see. Let's find out the length of the list first. So the length of the list is defined by the function called length. So it's an inbuilt function, so it will give you the length of the list. And then I will subtract one element because lists are 0 indexed. So this will give me the index of the element which I want to get. Okay. And then I have to find a way, I have to find a function or an operator. So basically operators are nothing but functions which are in infix notation. So let's say a plus b is, so in this case plus is an operator, but an operator is nothing but simply a function that takes as input its operands. So as I said, everything in Haskell is a function. So we should adopt this lingo of calling everything a function. So I have to find a function which can take my list as input. So I have my list. So this list comes from here. This is basically the input to my function. And so my list, and I have the index, and I should have a way to get this element. So the way to do in this in Haskell is to use the double exclamation mark function. So I know it's weird, like Python way seems more intuitive, but we have operators here, we have functions here. So yeah, that's how you get the last element of the list. And so yeah, and so now what I will do is I will define a list, and we'll print the last element. So to call multiple elements, multiple functions in Haskell script is to use the do keyword. So what I would do is I would first define a list, and this is how you define variables in Haskell. So the let function. So in mathematics we do let x equal to 5. In a similar fashion, in Haskell we do this, let list equal to some random list, let's say 1 3 6 1 2, and then let's print out the result of our function. So the space is actually necessary in Haskell because that's how this print function is syntactically different. And I will call my last function, and then I will give the list as input, and hopefully it would print the last element in our list. So let's go ahead and pull out our terminal once again, and I would again compile. It's compiled, and then I would run the script. It gives 2, and let's see, yeah, 2 is the last element. And if you want, so basically let's see if we can solve more questions from this. So it's the last but one element of the list, and so what I will do is so the second problem is last but one element of a list, and the third problem is the kth element of a list. So if I write a function to get the kth element of the list, then I guess this problem 2 is easily solvable. So what I'll do is I will modify this function to solve problem number 3 as well. So get element list comma k. So basically we are giving it two inputs. Okay, and yeah, so basically you are giving it two inputs, list and the index that you want to get, and then I would separate this with the index, so it will give me the kth element. And to so so the problem one was last element, and how will I do it using my new function get element. So basically it's get element, I would pass in the list, and I would pass in the index, and the index is nothing but the length of the list minus 1. Similarly, the last second element would be the same thing, just replace 1 with 2, and the kth element, where k is 2, so it would be nothing but print, and then we'll have our function get element and then the list and then 2. So yeah, that solves our first three problems, although I promised to solve only the first problem, but these three looked similar. And the fourth in fact we can solve the fourth problem as well. Find the number of elements in the list, and technically we have solved the fourth problem as well. So number of elements in the list, and how we do that, we are already using the length function, and it would give me the number of elements in my list. So yeah, and let's have a look at the so it's a reversal list. So basically there is an inbuilt function to do this, but I'm showing you an easier way to do reverse the list, and I hope it's easy, so that we can get the fifth problem away. But in the next episode, in the next video, I will revisit this fifth and I will revisit this fifth problem, because there is a nice concept called pattern matching, which will be beneficial to learn using this problem. But just for the sake of completion of the 5 problems, I'm using this reverse function, which will technically reverse the list. Now let's save our file, and where's the, yeah, compile it and then run it. So so this is our array. The last element is 2, last second element is 1, kth element where k is 2 is 0, 1 to 6. Our number of elements in the list is 5, and the reverse of the list is 21631. Just 21631. So yeah, we are done with the 5 challenges, and congrats. So you have learned how to write a function, what kind of definitions we are going to use, what kind of operations can we do on the list data structure, and hopefully you'll get to learn a lot more. And I'll target problem number 5 again, and problem number 6 and problem number 7 in the next video. So stay tuned, and if you have any suggestions, mention in the comments section, and let's learn Haskell, and maybe we can when we get over these 99 questions, we can do something good with Haskell, maybe write a kernel program, or maybe write an operating system from this new language. It would be exciting to write an operating system out of a purely functional language, but let's see how it goes. So yeah, see you next time. Goodbye.